High above our planet, countless rocks drift in silence, and the size of just one determines whether it becomes a fleeting streak of light or the catastrophe that ends everything we know. At the lowest tier of asteroid impacts are the fragments so small that Earth dissolves them before they ever touch the ground. These particles, ranging from dust grains to marble-sized stones, constantly sweep across our orbit. Earth plows through them day after day, and each one slams into the atmosphere at tens of thousands of miles per hour. The heat generated by friction incinerates them instantly, and for a moment they glow in streaks that dart across the sky. People make wishes on them, unaware that they are watching the violent end of ancient material older than Earth's continents. Earth absorbs thousands of tons of this debris each year. The vast majority vaporizes long before reaching the surface, but the process is still dramatic. As a fragment compresses the air ahead of it, temperatures spike to thousands of degrees, turning the upper atmosphere into a flash furnace. This streak of light is not just the object glowing, it's the surrounding air being superheated into plasma. Occasionally, a larger piece survives long enough to create an atmospheric blast. The 2013 Chelyabinsk event is one of the clearest reminders. A rock roughly 66 feet wide exploded high above Russia. The fireball rivaled the brightness of the sun, and the resulting shockwave shattered windows in thousands of buildings. More than 1,000 people were injured, yet the asteroid never struck the ground. It disintegrated around 18 miles up. Its energy dispersed before it could cause worse damage. Level 1 is dramatic, but it is not dangerous on a civilization scale. These meteors are reminders of Earth's constant collision with space dust, a silent background hum of cosmic debris that our planet handles with ease. Level 2 asteroids are not defined by destruction but by uncertainty. These objects, usually hundreds of feet across, enter astronomers' watch list because their early calculated orbits come with wide margins of error. When a new object is discovered, astronomers collect only a short arc of data, usually a few hours or days of observation. With such limited information, orbital predictions include a cone of possible paths, and sometimes that cone brushes across Earth. This does not mean impact is likely, but mathematically it cannot yet be ruled out. News outlets seize on these probabilities, often turning 1 in several thousand odds into alarming headlines. But as more observations refine the orbit, the uncertainty shrinks and the threat almost always disappears. Apophis is the best known example. When first observed in 2004, it appeared to have a small chance of hitting Earth in 2029. That hint of possibility sparked global concern, but additional measurements quickly adjusted the trajectory. By the time the orbit was well understood, the threat had vanished entirely. Level 2 asteroids are a reminder that the universe is full of rocks we are still discovering. They are rarely dangerous, but they highlight an important truth. Humanity's knowledge of near-Earth space is still incomplete. Uncertainty at this level is the only real hazard. The transition from harmless glitter to existential threat begins here. Level 3 asteroids, typically between 150 and 300 feet across, are large enough to survive the descent through the atmosphere. Instead of burning up, they retain their structure and most of their kinetic energy, which becomes the source of their destructive power. When such an asteroid strikes or detonates just above the ground, the energy released can exceed multiple nuclear bombs. Temperatures at impact can surpass those on the surface of the sun. A shock wave radiates outward, flattening buildings, snapping steel, and igniting fires across an entire metropolitan area. Meteor Crater in Arizona offers a clear illustration of what even a relatively small object can do. Around 50,000 years ago, an asteroid only about 150 feet wide hit what is now the Arizona desert. It excavated a crater nearly a mile across, lifting walls of rock and throwing debris for miles. The force of the explosion reached roughly 10 megatons, far beyond the destructive power of any non-nuclear conventional weapon. What makes level 3 so unsettling is the difficulty of detection. Objects in this size range are dim and often go unnoticed until they are relatively close. Some approach from angles obscured by the sun, giving little time for warning or preparation. It is entirely possible for a level 3 asteroid to appear in our skies with only days or hours before arrival. This level represents destruction on a scale that cities are not built to endure. Once an asteroid grows to about half a mile wide, the scale of destruction expands dramatically. These objects release energy thousands of times more powerful than any human-made explosive. A level 4 strike would obliterate not just a city, but an entire region, reshaping landscapes and altering weather patterns across continents. On land, the shockwave alone would flatten forests and urban centers alike. Rivers would redirect. Fault lines could destabilize, triggering earthquakes far from the impact site. The explosion would eject so much debris that a portion of it would fall back as fiery fragments, igniting igniting secondary fires over vast distances. If the impact occurred in the ocean, the results could be even more catastrophic. The displacement of water would produce towering tsunamis capable of crossing entire ocean basins. Coastlines thousands of miles away could be swept clean. Ports, shipping routes, and fishing regions would be devastated. In the atmosphere, billions of tons of dust and vaporized rock would rise into the stratosphere. For weeks or months, sunlight would dim, temperatures would drop, agricultural systems would falter. Even countries untouched by the blast would feel the effects as food supplies shrank and global markets destabilized. Level 4 is where a natural disaster begins transforming into an international crisis. Asteroids several miles wide push the consequences of impact into long-term planetary scale disruptions. A level 5 strike would vaporize everything near the impact zone, erasing entire regions with heat powerful enough to melt rock. But the most devastating effects would unfold not in minutes, but in years. After the firestorms died down, Earth would enter a prolonged impact winter. Ash and dust suspended high in the atmosphere would block sunlight globally, plunging temperatures and halting photosynthesis. Plants would die in massive numbers. With vegetation failing, herbivores would starve, followed by predators. The collapse of the food chain would spread across continents. The oceans, too, would undergo crisis. Acidification would accelerate as dissolved minerals and chemical byproducts from the impact mixed into the water. Phytoplankton, the base of the marine food web, would decline, and the loss would ripple upward to fish, marine mammals, and the human populations that rely on them. While humanity might survive a level 5 impact, our technological civilization likely would not. Global supply chains would break apart. Nations would struggle to maintain order amid resource shortages. Within years, the modern world could fragment into isolated enclaves of survivors facing a harsh, transformed planet. Level 6 asteroids, about a kilometer across, represent a point where the scale of disaster surpasses any historical human experience. A strike of this magnitude could erase entire countries. The immediate blast zone would expand to hundreds of miles, vaporizing everything within it. Shockwaves would tear through infrastructure, collapsing highways, power grids, and communication systems far beyond the initial impact. If such a strike hit an ocean, tsunamis could surge across entire coastlines, reaching heights capable of inundating cities and reshaping continental shelves. Shipping industries, fisheries, and ports would suffer catastrophic losses. The economic aftermath alone could destabilize multiple nations. Even regions untouched by physical destruction would feel the effects. The global economy is interconnected, and the loss of major hubs of industry, agriculture, or technology would trigger worldwide recession. Millions of climate refugees would cross borders, seeking stable food supplies, shelter, or medical care. Governments could collapse from the strain. Conflicts might erupt as remaining nations competed for dwindling necessities. Level 6 does not ensure humanity's extinction, but it ensures that the world before impact and the world after would be profoundly different. With level 7, impacts become not regional disasters, but global catastrophes capable of reshaping Earth's entire environment. These asteroids, several kilometers across, unleash destructive forces that push ecosystems past their breaking points. The impact would ignite continent-scale firestorms as ejecta rained down across the globe. Massive earthquakes could reshape coastlines. The crust would shudder from the shock, potentially awakening dormant volcanoes and intensifying eruptions for years. As dust, ash, and aerosols filled the atmosphere, sunlight would dim to a fraction of normal levels. Temperatures would plummet, growing seasons would fail repeatedly. Entire agricultural belts would collapse. The closest natural analogy is the Chicxulub event 66 million years ago, though even a slightly smaller object would be devastating. In the aftermath of such a strike, billions of people would face shortages of food and clean water. Modern systems of transport, communication, and energy would falter under the strain of global disruption. Humanity might endure, but only through extraordinary adaptation, and only in drastically reduced numbers. Level 8 asteroids push humanity to the brink. These enormous objects, perhaps 5 to 10 kilometers across, produce destruction that envelops the entire planet. Even the deepest, most fortified cities would not escape unscarred. Upon impact, temperatures near the strike zone could exceed those on stellar surfaces. Vast plumes of superheated rock would blast into space before falling back as molten debris. Firestorms would spread across continents. Shockwaves would circle the planet repeatedly, damaging or destroying structures thousands of miles away. The real threat is the aftermath. Sunlight could be blocked for decades, surface temperatures could plunge below freezing worldwide, crops would fail universally, oceans would stagnate and grow increasingly acidic. Ecosystems would collapse in sequence, leaving no stable environment for agriculture or long-term habitation. Humanity might survive in isolated, highly prepared refuges, but life outside these protected zones would become nearly impossible. Level 8 marks the threshold where the continuation of our species becomes uncertain. A level 9 asteroid is so large, often more than 10 kilometers wide, that its impact redefines the surface of the planet. The crater could span hundreds of miles. Entire mountain ranges might form or collapse in the aftermath. Shockwaves would trigger massive volcanic eruptions, injecting even more ash into the atmosphere and amplifying the already catastrophic climate effects. Tsunamis could cross entire oceans with repeated waves, reshaping coastlines globally. Wildfires could burn for years, fueled by the debris and altered climate. Darkness might last for decades. Photosynthesis could halt almost entirely. Most animal species, including humans, would face extreme difficulty surviving without engineered environments. This level does not guarantee extinction, but it renders civilization impossible. Knowledge, culture, and history could vanish as the remaining pockets of humanity struggled simply to endure. The world would become a frozen, toxic wasteland where survival, if possible, would come only in the smallest of enclaves. The final tier represents the true end of the line. Asteroids larger than 10 kilometers do not merely devastate Earth, they reboot life entirely. The energy released by such an impact would dwarf all other natural disasters combined. The immediate effects would include firestorms across the entire planet, oceans boiling near the impact zone, and shockwaves that travel repeatedly around the globe. Rock vapor would rise into the atmosphere, then condense into scorching droplets that rain down everywhere, igniting forests and burning ecosystems to ash. When the fires finally subsided, the world would enter a darkness lasting decades. Temperatures could fall to levels that freeze entire oceans. The biosphere would collapse. Species unable to adapt quickly would vanish in rapid succession. This level is what ended the age of dinosaurs, and it would end us as well. Even the most advanced shelters would eventually fail without a functioning global ecosystem. A level 10 impact is not a disaster. It is the erasure of complex life on Earth. Asteroid impacts are not speculative fiction. They are part of Earth's history, written into craters scattered across continents and hidden beneath oceans. Small impacts happen constantly. Larger ones are rare, but they are inevitable across geological timescales. The crucial difference today is awareness. For the first time in history, a species on Earth has the ability to detect, track, and potentially divert dangerous asteroids. Surveys like NASA's NEO program map thousands of near-Earth objects. Infrared telescopes scan the sky for rocky threats. In 2022, the DART mission proved that humanity can deliberately alter an asteroid's trajectory. The cosmos will continue sending us reminders of our vulnerability, but we are no longer passive observers. We are the first species with the knowledge and tools to defend its world. If this has sparked your curiosity about the dangers and wonders beyond our atmosphere, stay with us as we explore what else the universe is capable of. And when you're ready, dive into this video next. Thanks for watching.